Welcome. We're gathered to look back on the first 30 years and look ahead to another 30 of field robotics. It's had the good fortune to be the most successful initiative within robotics. A great deal of that is that it serves immense markets, but the other side of it is that it's an area that has been very strategic, very technical, and beyond the research has done a great job to move it in the world. That happened here. Could have happened anywhere, just happened here. And the people who made that work have gathered today and this evening. These are some of the 2,000 people who have touched the initiative over time. The earliest initiative developed the first work machine and put that into action. Sorted out a great number of technical matters. What would a working robot really be? How would that be controlled? What are the kinds of tools? What are the kinds of operations? And then went the distance to put these into a nuclear cleanup where they were the only machines that ever operated in that basement and are commended for performance. The other great vision of the time was the idea that driving might become important, it might turn into something. And that what came of that in the same year was this machine that we called the Terra Gator that went on to have an incredible lineage of navigation initiative, so many firsts over a decade, and really led the charge until surpassed by the NAV Lab a few years later. The other thing that was so great about that Terra Gator is that in the following year, it deployed into and underground into mines. Now this was at a time when the navigating robots in the interior were not succeeding. Most of them were acoustic sensors, which did not do well against the glass in the walls. And something so neat about this is that the processing navigation was aboard a VAX 750 bare board with a disk, and that it was very sensitive to the shaking and the temperature. But once it was up and running, it was amazing how it worked relative to the hallway rovers here. And it was just one of those first resonances where it was clear that field robotics was going to outrun a lot of what was going on in other realms. The third quick initiative was the first of the autonomous digging machines, an excavator. And we went after this because it was so distinct and unique relative to the kind of manipulation that was reasoning about how to grip and move discrete objects. This had to engage the diffuse world. And so each of these then went on to be incredible initiatives of technology application and wealth building, and they're going to be good for decades to come. So then whole lineages, just innumerable developments of machines, technologies, purposes. It's not possible to say too much about any of them. There's lots of eye candy, and so many people live these adventures. It's just not possible to go deep right here. And when I say people lived the adventures, paid the dues. Besides what is attributed to, say, field robotics, I'm just looking at the red machine that's up here now. This was, for example, the first project where Reed Simmons engaged. I recall Martial was aboard. Do I recall the structured light and the projected lines and the like that really no, and just you know, so many of the greats that you know in are blurred lines about what's field robotics and what isn't. Anyway, this went on then. You know, many expansions underwater, in the air, and that primeval driving. I was going to say evolved, but I got enough smiles to know that this was actually a death march for so many. I think they're going to bury Tony Stentz in this thing, and you know, it's in part because so in the proposal we were very lofty, and we made it this name, Navigation Laboratory. It's called the NAV Lab. But one of the unique things about it was building it so that the researchers would operate from inside, and that of course the upside is that it facilitated that very intimate, hands-on sense of what's really going on, and the quick turn of evolutions of the technology and the work. But the other is that it just eternity to get everything to work. And this was so many breakthroughs by way of the two-axis laser scanning and the very high-end color cameras, and the supercomputing. There was a whole era of it that actually was the deployment of what Carnegie Mellon called the warp, which was pretty big, pretty flaky kind of board. Anyway, very high accomplishments. And at this time, we're envisioning things like, oh, well, you know, the day will come when there is autonomous driving across the nation, and where autonomous driving will become an everyday accepted consumer expectation. So at some point, there was some there was some strategizing about what is this all about, where is it going, and what could it become. And at least we had this idea of a differentiation of genus, species, and certain kinds of machines that would come out of it. But I think we really shortchanged this, because maybe it should have had a whole quadrant for air vehicles, a whole quadrant for ocean-going and water vehicles and so on. But one of the measures of success is that it's no longer possible to do anything like this, to have a sense of how this has grown in the world, what the technologies are, who the people are. It's just gone so non-linear that whatever it is that we seeded is just, you know, it's not something that we can bear hug or hold on to. So 20 years ago, as that visioning occurred, we came up with this list, and literally it's this list, and I just cut-paste it from the great proposal. So you got to put yourself back when none of this was really going on, and we came out pretty strong. By the way, we took this to Congress, we took this to NASA, and we got this funded, and it became what Pittsburgh calls the NREC. So we had this thing where paint stripping is going to happen, and that this technology is going to make it big and mean something to the economy, to the nation and the world in the areas of, and you can read them. Now, you got to put yourself back, because there actually was a time before America deployed robots for planet exploration. And the biggest pushback that we got on this was, I remember at Congress, from the people and the staffers, I mean the Congress people and the staffers, like the real guys. What the heck could something like this do for farming? What do you even mean by automation of automotive? And how goofy is that? And of course, now you look at it and it's big business, it's inevitable, and you just couldn't put markets like this back in the can. It just doesn't go backward. And the other is that the technological drivers and the enablers, what is occurring in the sensing, what's occurring in the software, what's occurring in the computing, what's occurring in the machines is growing like a weed. So I call it the proposal of '94 because coincidentally it was the blizzard of '94. And you can see from the hot spot that 22 feet of snow fell on Pittsburgh after there was already snow in Pittsburgh. So we had this thing all cooked up, and Carrying for Fitzpatrick is name by name in it. A couple of people in here really went to the wall, and we couldn't get signatures because it was the 4th of January. So we got Raj ready in his home, and then I drove to Paul Christiano's, where we got the signature. We didn't get a department. We went out with it, and the rest is history. So the nature of the proposal isn't as big as the formulation of what would really occur. So about the farming thing, we promised it big and promised it early, and this is one. This is actually the early one. A lot of people in here are the ones that made it go. And also, what's occurred is that John Deere's in here, meaning that as a growth arena, this is one of the big ones. One of the markets that came out of it, along the way, one of the things we created was the guidance of an outdoor machine utilizing GPS. So it was actually before this thing, but it was like the big idea at the time when GPS didn't work very well. And these are just pictures of aftermarket things that you can now get. You get them from 25 or 30 suppliers. It's very competitive, very low cost. I'm not saying that the OEM isn't so much better, but this is an example of how it proliferates so far that you can't really see it all occurring. And then something very active in the community now and forever is specialty agriculture, where even in the talks today, I learned of projects that I was unaware of that just keep going. So we've seeded this, and you'd never guess. When we named it Field Robotics, we had a great deal of resistance. We had at first been calling nuclear robotics, is that what we did, and construction robotics, because that's what we did, and navigation laboratory, because that's what we did. But then instead of changing the name every year, we just called it Field Robotics. And people didn't like that because they said, wow, that sounds like farming, and we don't do farming. And of course, now we do farming. And it's going to keep going big. Now, it's not okay to have favorites, but this is one where, besides doing the basic work at Carnegie Mellon, I had the great privilege to develop this truck. Now, this is now 22 years ago. And of course, the university, joint with Caterpillar, has just done another round a superb commercialization of a great development. But it was a neat thing 20-some years ago to pull this off. Pretty hard going, and I think there were about a dozen patents in it. But it was easy. Of course, it's easy to patent in the beginning. You don't have to be very good just first. And there are so many more of these for the taking. You recall that first ideas of digging, much more progressive programs along the way, and many more to come. By the way, for those not familiar with construction equipment, whether it's graders or dozers or excavators, the high-end equipment on all the big jobs is now drive-by-wire, and so much of it augmented with these guidance technologies and controls for features that improve the equipment. And we've had a huge part of it. You know, we put site characterization and environment in it back in the projection. We didn't even know what we'd do, of course, in any of these things. But this is an interesting one that where this is one of those sites in Nevada where you're not supposed to know exactly what's going on for good reason. And then it is towing some some sensors where we never were allowed to really know exactly what it was. But because of the difficulty of putting humans on that site, there was a need to go over 2,000 acres at very high precision, at fairly slow speeds. And it is the first breakthrough where they were willing to take a shot on this. And we needed the money. And this is another of those big areas, but also one where every one of these, of course, those in the audience will revisit it again and again and again over the decades. And you have to imagine how wonderful that these solutions will be as they're iterated. A tremendous pioneering under the ground, and a big one yet to come. So mining is coming on strong, not just the rescue and the safety and the like, but the mining operations. And even the coal in this region it will be remined because it's a fortune of energy. And it's not possible to put humans into the abandoned mines, so these machines will be the means for that. This an imaginative environmental development to remove asbestos. And then, of course, the navigation didn't stand still, and it went from driving the streets to pursuing the higher performance and going off-road. Immense technical progress. Some of the things that's so fantastic about these competitions is that they are a leap of technology. They push it so much faster than contracting or deliberative, stepwise research can achieve. And then that also led to a great deal of new planning models. Of course, all this is gestating in various ways, but I would say that this line of research implemented at a rigorous level for the first time what we now call behaviors, contexts for intersections, context for parking, context for passing, and it is it's actually magnificent to be in a community where so many who have joined today are really pushing this into the commercial market, and in many cases through the OEM automakers, that this is one where within 10 years, both the commercialization and the regulations that empower the driverless driving are forgone. The development and the technology still matters for decades in all these things, but those good enough implementations to get you around will be a sure thing by that time. You know what to say. We've done well. Done well. About the doing well, the consequences of this particular line of work is that the significant improvements in safety are already underway, and those will be realized to a great extent in the next 10 years. Already, there are features that preclude certain kinds of accident, not the big ones yet, but that is authentic motivation. It's not the only story. Also, that idea of expanding the driver experience really is so, both by way of age and on both ends of the scale. I'm not so sure it's okay to carry it so far to pluck the heartstrings about the motivations of driving for the blind and driving for the very aged and the like, but the legitimate motivations, technologies, and trajectories are making it happen. And the automated trucks, by the hands of this community, are already implemented, and with much more to come. It's not just heavy iron. So many of the technical developments are reaching the world. This particular one is Braille training for the blind. I mentioned space as a motivation, and at the time, the congressional response was that there won't be robotic explorations of the planets because it can't be funded in Congress. It won't have the popularity, the romanticism, and the heroicism of astronauts. And robotics isn't worthy, meaning that it can't do anything. Now, I'm not saying it's done deal, but 1997 did a little, and then a little more, and a little more, and a great deal of that was formulated and led here. Got some communications today from some of our spacefaring alums. Sometimes the Jet Propulsion Laboratory is referred to as the house that Carnegie Mellon built. And they couldn't be here today because they're tending a rover on Mars. But of course, our day is coming. And these were very heady capabilities. So we were clocking 100-kilometer missions at a time when that first Mars rover was inching its 88 meters. So it's not possible to say everything about it. One of the innovations on this is the spherical camera. The I really can't let these things run at length. The other I'd mention is that these were the means for thinking machines. So this is a shot of the meteorite hunting in Antarctica. And Bill Cassidy has joined us for the day. He is the premier scientist and leader of this visionary work. And then through and with him, this developed the first that I would really credit as a great classifier and also a great physical search engine. And it's so neat that both the team and the PhD that developed a lot of that is here with us today. But you know, it really, there was a day when robotics was just navigating, getting from A to B and staying out of trouble and avoiding obstacles. I hate to say it, it went on for too many years. Probably still going to keep going on. But maybe it's not the big one anymore. Of course, many forms, these ones that go into the steep holes have become relevant because over the last 2 years, the steep holes have been discovered on both Moon and Mars. More than 100 on each of them, and these are steep-walled holes that could contain this building. We intend that as destination for our landing in 2 years. The air vehicles are coming strong, and some of the big breakthroughs were the high-speed maneuvering through the obstructions, and the other, the control landing of full-sized helicopters, both for cargo delivery and for medevac rescue. And of course, it's no secret that there's a bold new company that is pushing the agenda on this front, and vast agenda within this institute that's moving that along. The transformational moment for this will come in the next few years when there is increasing authorization for using these vehicles within the commercial airspace. And when that occurs, the skies will be filled with variations of these machines. So beyond the generic space, we're on the way to the moon. And that takes us into a realm which is beyond the basic issues, and and requires us to face off with the vacuum, the temperature, the radiation, the shaking, everything that's required to succeed. This is an embarrassingly small list because even the people who join us today have many, 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 many more companies and initiatives, and I mean, I'm looking out. I didn't even list Hyperactive that's sitting right in front of me. It's an embarrassment. It's not possible anymore to list these many companies. It's also interesting how many of them have stayed at home or in the area in order to build the game, and it's a huge, huge aspect of what we are and what we're becoming. So easy to look back, and it's our job to look ahead. I mentioned that the air vehicles will really open up in large part because of the technology, and in large part because of the alignment of regulation that makes it possible for them to work in new ways and more ways. And when I say within 20, I probably mean within 10 for most of this. And you got to pick your own shot, but you'll note from the last projections that we go for what will deliver. And that the auto-driving features will be pervasive. Also, the regulations that facilitate those will be changed a state at a time, a feature at a time, and that landscape will look very different. The classics, the mining, the farming, building, will really come into their own. By that I mean that these applications and technologies and compelling markets are just feeding on each other. This business of passive to very active machines is a big deal. For example, you take our sewer operation company, Red Zone. It's a phenomenal market, phenomenal technology area. It's going to grow and grow and grow. And think of how much has been done, but it's mostly inspection, modeling, evaluations, and the like. And then the reality is that our infrastructure is crumbling, and it's just calling out for the active motion to get in there to repair, to build, to rebuild. Similarly with so many of the operation, like so much of the mining has been rescue, modeling of abandoned mines, passive presence, or operation and hazard is often the operation to observe in the presence of gas or hazard, but maybe not do so much about it yet. And that table turns over the near term. About the super sensing, there was a day when radars could determine, those are cars and that car is moving, and a push like the Challenges would add. The physics don't change, but the high-end processing changes so that you can pick out the fence posts, pick out the trees, pick out so many other details, and there's huge headroom in that. My sense is that 20 years from now, flash LiDAR is the resolution and the quality of cameras that we have today. That in our game, the weather tolerance is tough, but the ideas to overcome it are huge, and many of these things are commoditized, not just the parts, but the whole machines. We used to look in terms of serial processing, and a very classic metric for many years in navigation were the MIPS per meter per second. How many MIPS required for all the processing for a whole control loop per second. But what's occurred are these computational devices like FPGAs, the geometric engines, very specialized silicon, where these things are so parallelized and parallelizable, and where there is a sense of how to solve these problems at the immense scale that's required in speed, that it's more like what does it take for a control cycle, which is very small in power, very small in device, and getting more so very quickly. There's so much that's untouched. There's nothing that's going on really that is servicing hotel rooms. I mean, how many beds are made every day? How many rooms are cleaned? How many times does the soap go in the same place? And how much of a business is that, and how profitable is that, and how much of a technology could a community like this bring behind it? They're no-brainers. The thing is that it's such a rich target opportunity that whether it's technological or application or enterprise, there's a lot there for the taking. Now, this 100-fold is something that is occurring on so many fronts. And there are a lot of different ways to talk about it, but it's actually, let's say that there is a mine explorer, and by necessity that has to be battery. So you can't use an engine and you can't use solar. And it might be a standard that you could operate for a kilometer. And it's a kilometer because the robot is massive and a power hog, and the sensors are massive and they're power hogs, and the batteries are lousy, and the computing chews up power, and that because it is a dark setting, it requires active sensing of some type, and it's never been optimized. And I wouldn't be shocked 10 years from now if somebody pulls off 100 kilometers. I mean, how much better are the batteries getting? It's not, I'm not saying that this community is all doing it all, but those ingredients are definitely in there. It's one of many, many, many. So interesting to see the things like the stereo modeling, where depending on how it's done and what your prior metrics are, in many cases have improved 100-fold. The challenge races pushed the SLAM-like solutions 100-fold. The thing is that there's plenty of 100-folds left in them, and they're ours for the taking. So about the application realms, all I did was copy the ones that we had from 20 years ago, because none of them are handled and none of them are going away. And they're no-brainers. It is. It's a great setting. It's, there's also, I mean, there's absolutely no question about any of these. None. And then, of course, it doesn't preclude imagination about taking on other matters of the type that I mentioned. So I'm not taking us off the hook. It's just that as a community we lead, so it's up to us to keep pushing it. And in a big way, those 30 years, well, in an entire way, those 30 years are the people. And in a big way, today, and particularly this evening, are about those people. And that's been, of course, quite a wonderful and motley crew. It was everything from casting the vision to conceiving what are those critical developments to undertake, and then going after them with a way that we're like really going to do them, and all of the grind that was required to pull them off, and that it remains a very progressive, very collaborative community, and beyond all that, a lot of good friends. So there's no big story about some of these, except that a very few old-timers would recognize that there was once a concrete ship's prow at the end of campus, and that this movement was in full action long before that was removed to become a building. And that many of the pioneers in this photograph are with us today, and that was one of the early manifestations of that outdoor navigation machine. Most of the people in this meteorite hunt, including the scientific leader, are here today. I don't know that I told the punchline, which is that it actually found meteorites. As a community, besides the air and land, sea, and air, it's been on the water, under the water, and underground. Above the Arctic Circle, below the Arctic Circle. So it's actually been on all the continents and both the poles. And always teams. Takes a village, takes a lot. This was the first of the racing teams. And the later racing team. And then what counts are the many people who gathered today and this evening who are the great hearts and souls that put it all together. That's the story. Thank you very much for the day. So, any questions, curiosities? And please feel free to answer them here. It's not like I got any magic. Yes, Sanjeev.
So we heard about what's inevitable.
Yes.
What's still hard? What are the open questions?
My sense is that even in the coming decade, we will not get machines that, and for example, in the driving realm, we are not likely to get machines that are anything close to the generality required for all driving conditions. I think things that are particularly hard are the tough visibility, tough weather sensing problem, and what it takes to have the assurance and reliability in those conditions. There are so many uncertainties that go with changing traction and ice. Forgetting all that, just the vagaries of other drivers and the things that can occur, just tough to get them all. And just like what we have is good enough to get it into a mine and work, those will be good enough to get it into a market and make first inroads. I would say that although we have the sufficiency of robotics brand of perception, it's nothing close to the combined richness of the perception that each of us enjoy just being here. You know, that combination of what are you perceiving in all modes and how that's blended together. And then the physiology of these machines is primeval. I mean, really, these things are, of course, not yet specialized for automation purpose. The only way we get things to work is to have these big pumpkin sensors sitting on them and taking machines for other purposes and just driving by wire. So that has to be thought through from the beginning. Those are at least a few of them. But others might offer, like, what's really tough? and is not going to fall in the next 2 decades.
Well, I think the key question, Red, is that who cares?
Yeah.
And the economy of the whole thing, and and the impossibility and of the problem is what really will drive it, right? And kind of prioritizes what are the tough problems that one wants to attack.
Yeah, it's important to not come off as being imperial in the matter, but it's always been a matter of who cares. When we received the commendation for the service and the cleanup of the 3 Mile Island accident, there's a lot of conversation in this community. Well, that's not really a robot, and who cares? Or that you hammer away for 150 miles of robot racing at a pretty good speed, and people will say, well, that robot isn't reasoning, it's not writing poetry. Who cares? Maybe the real question there is, what is it that we owe, or as a community, what do we owe to the world if there is such a concept? Because maybe we do, and I wouldn't be light with that. But here's an internal example. Navigation was really, really proceeding here at Carnegie Mellon. And we had this wild out idea that rather than modeling and reasoning from those models, maybe GPS would have utility for guiding an outdoor machine. And we felt strongly about it. We pushed on that. And we were invited out of a lot of research that was occurring, but to push on that until it fulfilled. And of course, it is the means by which outdoor machines fundamentally, at this time, navigate. And it was kicked around pretty hard. And who cares? I mean, you live once, right? Who cares? But the other side of it is that, and so the idea that, okay, it works, it's got market and it's got future, that's great. But the thing that is so wonderful, I believe, is the magnificent balance between that very, very, very fundamental, difficult, engaging research and how tough those impossible problems are, and also what somehow we got going on the operational side of it, so that we somehow kicked it out in the world. Something else. Yes, Chris.
You mentioned briefly in one slide the regulatory and legal
Yes.
challenges that
Yeah.
are, and Pittsburgh is blessed with a great law school. So is there going to be some collaboration between the technology and the legal aspects of robotics?
It's such an intriguing thing where about this, so this relates to legal. One of the things that is well known is that we've crossed the line plenty of times. But not always in like an underhanded or devious way. For example, when we first developed the mine exploration technology, we were looking for the opportunity to get into an abandoned mine. And it's illegal to do so in Pennsylvania. First, they're not allowed to be open, and if open, no human can go in, given the dangers. But we put the word out, and we were looking. And then one of them got nicked over in Burkettstown. And we got the call. Now, that before going in, I made the call, a direct call to Carnegie Mellon's president, and also an email. He put it in printing. And I told him, look, this is the right thing to do. It is a really big deal, but literally, it's disallowed. And you know, in the true Carnegie Mellon fashion, the response is, we do the right thing, good luck. But there are many of those. Now, the thing is that even in nuclear, there was a time when all the regulation was written for the exposures of people and humans. And then all kinds of issues like what can you do to drill a hole through a containment that's designed to contain, and so many, but I'm not really, I mean, the point is absolutely legal matters. Yeah, absolutely, in all these things. And from time to time, politics matter. One of the reasons that Nevada is always my favorite state for field experiments, and I mean, it's not just, it's wide open. It's one of the last states that still has that Wild West adventuresome, and that ability to let these machines loose and get out there and pour in the miles and the like. And of course, they were first to adopt the tentative licensing to permit the commercial driving. But it matters. And oh, I didn't mention, you know, we've been so blessed with the nurturing of a region, the nurturing of political movement, of the nurturing of very favored, I say very favored circumstance. Something else. Yes?
Something we do know is going to happen is that you're going to send something to the moon. Would you just care to give us a brief summary of kind of where things are and how you're doing it?
Sure. So the first I'd say is that it is a pretty straightforward deal. There is a rocket, and that is from the very interesting Elon Musk SpaceX. And that we have the agreement for that to launch late in 2015. Our tentative date is the 19th of October, so it's about 2 years exactly from now. And then the other two parts are the ones that we're responsible for, we meaning the community. And we've gestated it all in CMU and moved some of it out to a company, Astrobotic, where the lander development is and the enterprise and the integration is being led by Astrobotic for all kind of good reasons. And then the robotics part of that is the Carnegie Mellon lead. It's a pretty simple-minded thing. You land, you drive the first 500 meters, and you get the first 20 million. Then if you go, when you go 5 kilometers, because 5 kilometers isn't that big a deal for us. There's a bonus of a few million. There's a bonus of a few million for operating after and during a cold night. There's a bonus of viewing historical hardware like a Surveyor or an Apollo or something like that. We are, the economy and the boldness of our approach is that we will utilize all optical guidance getting to, orbiting, and landing on the moon. And something just serendipitous is that there's now complete high-resolution camera coverage, 100% of the moon's surface, down to the scale where it shows each rock. And so the lander will carry that model and register to that terrain model, and from that back solve its 6-axis pose and fit that to the physics of motion. So we have another contract which is pay on performance like Lindbergh. It's 10 million. And we get that for landing, but there are also bonuses for the precision of landing. And if we were so fortunate to land on our target, which would be the accuracy of the roof of this building, then it's a very, very big boost, meaning 100-meter accuracy, which is never achieved, would do the job. So where we are is a very, very economic approach to everything, but some of the technology is first and bold. I would never give any of these ventures or any of these technologies good odds, any more than I'd give any startup company good odds. I'd love to hear it if anybody in this room ever had anything come easy. You know, it just don't work that way. So, you know, but the only way we're going to do it is to swing. And one thing I will say about this initiative is that it's pretty much always swung for the grandstands. You know, besides going a little big, going a little bold. Now, I want to make clear, none of that is me. And this, you know, it's the point where I don't matter so much in this or any of the other ones anymore. But I think beyond the diet of contracting and product development and incremental research and development, there's something to say for having a little bit of these kinds of things in the portfolio. It's not something you do steady state. And a great example of it within the Institute right now is the DARPA challenge. I'm not sure what the language is for it. What do they call it? DRC. So this is the one which is a work machine, which, by the way, harbors that technology and direction for those active machines that engage and work, as opposed to the passive presence that observe and inspect. I'm sensitive about the time. There's certainly no need to protract. Is there maybe a last question? Or maybe it's just the right time to get on with whatever's next. Thank you so much.